Hello and welcome. We are going to be using this particular book for Algebra 2, and it is by McGraw-Hill, and we will systematically be going through each chapter to help you grasp the concepts and see some examples for the exercises. I am Miss April, and this is Chapter 1 on Linear Equations and Inequalities. This kind of should be mostly review from Algebra 1, but let's get started. This video will be broken up into two parts, but part 1, let's go ahead and talk about simple linear equations. Okay, so simple linear equations, you might be familiar with y equals mx plus b. All right, I teach my algebra students to memorize this by saying y mix add butter. Right, it's my baking mnemonic. So y mix add butter, and this is a very simple equation, and it's in linear form. Linear, and it is actually in what we call point slope form. Now, whether I put the y on the left or the right, it doesn't matter. I could substitute the variables, y and x, for something else. Maybe you're familiar with standard equations that more might look like this, right? It doesn't matter. Which way you flip it, the value doesn't change. To be able to arrange this in any form. So if we, as the book puts the example like this, and it uses different variables, either way, these two are the same equation, okay? If we want to solve for x, we have to rearrange it, right? So for example, whether you're beginning with this one or this one, you're solving for x. We will first, let me rewrite it over here. We want to subtract b from both sides. We'll write out every step and divide by m on both sides. Law of equality states that what you do to one side, you must do to the other. So that gives us the solution for x, and that would, if I used these variables, it would look like this. Either way, that would be the solution. And the goal is to get the complicated, simple linear equation into its basic form always. One of the guiding principles of algebra. So, let's solve for a variable here in exercise. Let's see. We don't have solving for variables. So exercise 1.1, let's do an example. Let's take number 3 and solve that one together. Okay, so our observations for this particular equation should be that there's only one variable, and that is x, and we're asked to solve for x. Now, When I see something that looks like this, the very first thing that I want to do is to clear the fraction state, right? I don't like to see it in fraction form. It's messy, and if I have it simplified, I can more easily solve it for x. In order to simplify the fraction, I need to find a common denominator. Now, these are large numbers. What can be done is that you can think whatever 13 times 17 times 4 is. To save us from doing all the multiplication, if we multiply each term by 13, 17, and 4, then we can see that we don't need the 13 here, but 17 times 4 is 68. So we have 68, and then we have our numerator there, 21. Okay, now for the middle term, we have 13, 17, and 4. If you remember, these 17s will cancel each other out. So then what we have is 13 times 4, which gives us 52. So we have a 52, and then we have the 2x minus 3. And then this one will also have to be times 13, times 17, and times 4. 4's cancel out, and we're left with 13 times 17, which gives us 221 times that binomial. Now we have to utilize the distributive property for each of these terms. So 68 times x is 68x. 68 times 21, and we're using this operation, the addition there, it is a positive answer. 68 times 21, 1428, and don't forget to drop your addition there. And we have 52 times 2x. 52 times 2 is 104 in the x, and now we have a negative here. So 52 times a negative 3 gives us a negative 156. And we get to 221x, and then 4 times 221 is 884. Now comes time for the simplification. We have this term, this term. That can be simplified on the left. And we add this together, we get 172x. We have these two constant terms. And if we subtract 156 from 1428, we get a positive 1272 equals, we'll just write this down here. Okay. Now, always the goal is to have the x on one side. So our variable, we'll shove it to the left, which I always like to see x equals something. Makes sense to my brain. So I will subtract the 221x from this, and yes, we will have a negative, but it's okay. And then we will wind up with pen issues. We have the negative negative 49x over here. Now we will shove this over here, which gives us a negative 2,156, and we divide by a negative. Negative divided by a negative goes ahead and gives us a positive answer of x equals 44. Now let's look at linear inequalities. Inequality symbols are greater than, less than, greater than or equal to, less than or equal to. Okay. In primary math, you learned that you had a number line, and hopefully that's the origin. You learned that when you graphed a number, perhaps let's say you had 2 is greater than x, for example. So let's go ahead. Well, that didn't do what it should do. So we have 2 here and negative 2 here. I established my units. So every tick mark is 1 unit. You should at least put one number in the positive direction and one in the negative direction to establish your units. So you probably learned if x is, so if I just flip this whole thing, I can say x is less than 2, right? Oh wait, that helps me to understand it. If you can maneuver your inequality so that the x is on the left, and then you say it out loud, x is less than 2, that's helpful in graphing it. So I find my 2, and it's less than 2, so it's all of this, and you probably did the dots, right? And open dot is less than or greater than, which means it does not include the 2. And then if you filled it in, it would mean that you did include the 2. Here we're not including the 2 because there's no or equal to sign there. Now you should also know that most algebra books will go ahead and today use a parenthesis, and then you fill that in. And if it includes the 2, then you would be using a bracket. And this is helpful for the notation. For example, given x is less than 2, I can do this. I know that doesn't include. It's a less than or greater than, so we have brackets on both sides for the notation. And infinity, it goes to infinity, right? There's no stopping point. So infinity, and I use a comma, and it doesn't include the 2. And this parenthesis tells me it doesn't include the 2. Had the symbol looked like this, then that would be infinity. Anytime there's an infinity, it's always a bracket because infinity is not a specific number that we can include. Then we have the 2 and the bracket. So that's the difference between the notation with these 2. Okay. Now, sorry, I messed up with that. That should be a negative infinity, not a positive infinity. Yes, we have negative infinity and positive infinity. So this way, negative infinity. This way, it is a positive infinity. So if we have something a little more complicated, and I think that I would like to just go ahead and do one of your exercises to show you. So in 1.2, number 1, we have 8 plus 3x is greater than 5x minus 14. just like if it is an equation, we want all the variables on one side, we still want that. So I am going to add 14 to each side here, which gives us the 22. And I will subtract the 3x from each side. Okay. And remember that we have a rule, if we divide by a negative, we need to flip the sign, right? Now here, the goal is to have a variable alone on one side. So we're just doing our algebraic math. We have 11 is greater than x, or I like to flip this, and you're just putting the mirror image. Okay, 11 is still greater. If I put the 11 on this side or this side, it doesn't matter. And just make sure that your sign is flipped when you flip your variable. And constant. So I need to graph this. And I know the book is using the dots and open and closed dots, but I prefer to use, you know what, I'm going to have to change that unit. I prefer to use the parentheses and the brackets because it helps with the notation, which you do need to know. So I have an 11. It's a positive 11. So maybe I want to go ahead and go up by 5 each time. Alternatively, I could get rid of the tick marks and just put an 11 on one side, positive 11, and a negative 11 on the other side. Okay, so that puts me at about here, right? And it is less than, x is less than 11. So you know what I'm going to do? I'm going to change my color. And I'm going to do a nice little parenthesis here. And you shade in everything this way. So that my notation then would be negative infinity and 11. And I still have the parentheses. So hopefully you can see that it's actually quite helpful to do the parentheses on the number line or the brackets whenever you're graphing rather than the open and closed dots. Okay, let's do another one that might be a little more complicated. So what we can't have in the center here is, all this. We need the x by itself. Comparatively, that x value, we need to know what's greater and what's less. So let's simplify. And because the 14 is positive, let's subtract 14 from all terms. So you have three, essentially, you have three sections of this particular inequality. And that's okay. But it needs to be simplified to look a lot like this. Right? The x has to be alone because that's what we're using for comparison. It gives us sort of a window for the actual value of x. And we cannot determine that window when there is a coefficient or some other constant in the center there with it. Because there are three sections, we need to subtract the 14 from every section gives us a negative 20 here. It completely removes it from the center. And here we have a negative 2. Now we need to divide by a negative 5. Anytime we multiply or divide by a negative, does not apply to addition or subtraction, but just multiplying or division by a negative in an inequality, we need to flip all of the inequality symbols. So when I go to rewrite this, I need to be mindful that it needs to be flipped. Negative 20 divided by 5 gives me a positive 4. And this is removed. I finally have x by itself. And I have a negative 2/5 here. Now, convention states that I want my symbols facing this way, okay? And whatever the value here is. So I need to start from the least and from the least on the left and move up to the greatest. So negative integers possibly would be on the left, though you could have negative integers on the right, but you're still going from least to greatest. So with that in mind, we need to flip this entire thing. When we do that, we put the negative 2/5 on this side. X is still in the middle, and the 4 is over here. Now I missed something. Oh, this is an equal or equal. There we go. Oh, try not to do that. You lose that and it's not graphed right. Don't do what I just did. So we could graph it. Now that we have a less than or equal sign, remember that does get a bracket. So if I just put 2/5 here and my 4 over here, reasonably speaking, this would be much closer because it's less than 1. Okay, so this side then would have a bracket because of or equals to. We put the bracket, and we have a 4 on this side, and that gets a parenthesis because it's just less than symbol. And we can see that the window basically is in the middle between those two. So it does include the number negative 2/5, does not include the number 4. And then our proper notation for this then would be negative 2/5 and a 4 with a parenthesis. And basically we're just taking that bracket and that parenthesis and then the numbers that we've established that are here. Okay? It's so much easier than the dots for translating the graph into proper notation. Now you may have a union or a disjunction that you have to deal with. So let's take a look at an example with that. So if, for example, number 5 reads as 3x minus 5 is less than 4, or 5x minus 9 is greater than or equal to 16. Now, when we have the or, we really do need to sort of solve these individually and then make sense of it. So I'm going to put this on a number line. We have our origin. X is less than 3. So if I put my 3 here, oops, that's okay, on -3 and a +3. We have a 5 here, -5. Okay, so X is less than 3. Here's 3, and let me change my colors. So it's this here, and everything this way. And I will change my color for X is greater than or equal to 5. So 5 is here, and I'm using a bracket because it's or equal to, and it's everything this way. So we have a gap, and when we have a gap like this gap, we can't just have something simple in notation, right? So we have to join them somehow. We can write the first. I have the 3 there. I have the 5 there. See how easy it is just to drop that bracket or parentheses. Now I have a negative infinity, and I have a positive infinity. Remember, infinity cannot have a bracket. It'll always have a parenthesis. Okay, so what goes in between is a little kind of union symbol. Okay, and that tells someone looking at this particular notation that it does not include any number in between. It's sort of, there's a gap there, there's a hole. You can kind of envision it as a hole, right? But the value of X then is anything less than 3, but it is also, or could be, 5 or anything greater than 5. And that's what that means. Let's do an example of what happens when the numbers actually overlap. So for number, let's find a good one here. Let's do, well, number 6. So number 6 gives us 7 minus 5x is less than 22. And then we have an or again, 3x plus 7 is less than 22. And again, we will have to solve these individually. Now, you could see that we had to flip that on the left. And let's go ahead and graph. It looks like, yeah, that's good. So let's go ahead and graph these. let's do x is greater than -3, but it doesn't include it. So there's -3, and it's everything moving in the positive direction. X is less than 5, so it doesn't include 5. So we have a bracket, but it's everything less than 5. Do you see what's happened here? We basically have all real numbers. And I know that we said it doesn't include, because we have the bracket there, it doesn't include -3, or it doesn't include 5. However, this symbol or tells us that it's this or that. And because it's or, if it were and, this is a whole different story. But because it's or, the answer is all real numbers. And you can write that. You can write all real numbers. Or you can write that in proper notation, which includes everything negative and everything positive, infinity, and that's all real numbers right there. Okay, I will see you for part 2 of chapter 1 next time.